Electricity and magnetism are closely linked and together form what scientists call electromagnetism. When electric charges move, such as in an electric current through a wire, they create a magnetic field around them. This means that electricity can produce magnetism. On the other hand, if a magnetic field changes near a wire or conductor, it can cause electrons to move, producing an electric current. This is known as electromagnetic induction, and it's the principle behind how generators produce electricity. When charged particles interact, they create both electric and magnetic forces. Electric forces arise from attraction or repulsion between charges, while magnetic forces occur when charges move. Together, they form electromagnetism, which powers technologies like motors and wireless communication. Electric charges are a fundamental property of protons and electrons, which make up every atom. Positive and negative charges are the two types of electric charges. Protons possess a positive charge, whereas electrons carry a negative charge. According to Coulomb's law, the size of charges and the distance between them are both key factors in determining the strength of the electric force between charged objects. When you rub a balloon against your hair, electrons from the atoms that make up your hair transfer to the balloon, which makes your hair positively charged due to electron loss. The balloon becomes negatively charged due to electron gain when you hold the balloon several centimeters from your head. Your hair stands up due to the attraction between the two opposite charges. The charges that collect on an object don't stay there forever. Eventually, they make a sudden escape. This quick burst of moving electrons is called an electric discharge. Ever felt a tiny zap after touching a metal doorknob right after walking on a carpet? That little shock is a small but real example of electric discharge in action, nature's way of balancing out the charge with a surprising J. Direct current, DC, in this type, the electric charges flow in just one direction, like a straight road. Batteries are a common source of DC. They provide steady, one-way current to power things like flashlights, remote controls, and phones. Alternating current, AC. This type of current flows in one direction, then switches and flows in the opposite direction, over and over again. Conductors are materials that allow an electric current to flow through them easily, while insulators are materials that resist the flow of electric current. Energy source provides the push for charges using an electric field, like a battery's terminals. Load uses electrical energy to do work, e.g., light, motion, and resists current flow. Wires, low-resistance conductors that carry current between components. Switch opens or closes a circuit by connecting or separating metal contacts. Type of circuit. Current flows in a closed circuit but stops in an open one. Series circuit. Nodes are connected in a single path. Current flows through each one in turn. Parallel circuit. Loads are connected across the same voltage. Current splits between them. Ohm's law describes the relationship between electric current and voltage in a conductor, stating that the amount of electric current flowing through a conductor is directly proportional to the voltage that is causing the current to flow. Magnetism is a force that attracts or repels certain materials like iron, caused by moving electric charges. Magnets have two poles, north and south, where the force is strongest. Like poles repel each other, while opposite poles attract. Magnetic fields are invisible but can affect objects at a distance. Earth acts like a giant magnet due to its magnetic core. This magnetic field makes compasses work by aligning the needle north-south. It also shields us from harmful solar wind, making life on Earth possible. Without this field, our atmosphere could be stripped away over time.